Over $300,000 in motors are sitting at the dock. That is the reality for owners dealing with Mercury's Verado V12 outboard failures. What started as revolutionary 600 horsepower engineering has turned into a service nightmare, with steering sensor malfunctions, mysterious oil leaks, and guardian mode lockouts that leave boats stranded offshore. How did the marine industry's most advanced outboard become a cautionary tale that has even loyal Mercury dealers questioning the future? Let's break down exactly what went wrong. February 2021. Mercury Marine drops the biggest announcement in outboard history. The Verado V12, 600 horsepower, 7.6 liters of naturally aspirated V12 fury, wrapped in technology nobody had seen before. The headlines wrote themselves. First production outboard to crack 600 horsepower. First with a genuine 2-speed automatic transmission. First with a fully steerable lower unit controlled by electro-hydraulic actuators. On paper, this was not just evolution, it was a complete rethink of what an outboard could be. The numbers backed it up. 1,260 pounds of engine-producing torque curves that made 40-foot center consoles launch like bass boats. Where traditional outboards needed 4 or 5 units hanging off the transom, the V12 promised the same power with just 2 or 3 engines. Less drag, better fuel economy, cleaner stern layouts. Dealers reported MSRP pricing starting at $77,000 per engine. Loaded configurations with premium paint and extended warranties pushed past $100,000. But buyers lined up anyway. The waiting list stretched months. Early adopters included high-end yacht owners, offshore charter operations, and performance junkies who wanted the bragging rights of running the most powerful outboard ever built. Initial sea trials delivered. A Boston Whaler 420, Outrage equipped with triple V12s, hit 63 miles per hour and settled into a 43 miles per hour cruise, returning 0.7 miles per gallon. That's nearly 100 miles more range than the previous quad Verado 400 setup. Reviewers couldn't stop talking about the silence. At idle, the V12 was ghostly quiet. At speed, the deep hum of 12 cylinders felt more like a luxury sedan than a marine engine. The 2-speed gearbox was the real game changer. First gear used a 2.97-to-1 ratio optimized for getting heavy boats on plane. Once up to speed, the transmission shifted seamlessly into second gear at 2.5-to-1, dropping engine RPM and cutting fuel burn. The shift was so smooth most captains couldn't feel it. Software monitored throttle position and water resistance, choosing the optimal gear automatically. Mercury and ZF Marine Co. developed the gearbox specifically for saltwater punishment and the massive loads of a 600 horsepower engine. The steerable lower unit was equally impressive. Instead of swinging the entire 1,260-pound engine for directional control, only the gear case pivoted. Electro-hydraulic actuators responded in milliseconds, allowing up to 45 degrees of rotation. This let boats mount multiple V12s just 27 inches apart, opening up usable stern space. At low speeds, the precision rivaled pod drives. Docking became effortless. At high speeds, the system delivered razor-sharp turns without drama. Dual contra-rotating propellers completed the package. 2 props spinning opposite directions on the same shaft eliminated torque steer and maximized grip. The forward prop bit first, feeding water into the rear prop's slipstream. Cavitation virtually disappeared. Testing showed 20% better thrust compared to single prop designs, especially during hard acceleration and aggressive cornering. Mercury marketed the V12 as a luxury experience. 200-hour service intervals, 150-amp alternators, advanced range optimization software fine-tuned fuel delivery in real time. Compatibility with joystick piloting enabled effortless close-quarters maneuvering. Everything about the V12 screamed premium. Then reality hit. August 2023. Mercury issued a voluntary recall affecting V12 engines in Australia and the United Kingdom. The problem was faulty steering position sensors forcing engines into Guardian mode. When the sensor detected abnormal readings, the engine control module assumed a safety threat and immediately cut power. RPMs dropped. Throttle response vanished. The steerable lower unit locked into a narrow range, leaving captains with minimal control. Forum posts from owners painted a grim picture. Boats losing steering 30 miles offshore, engines dropping into limp mode during tournament fishing. One owner with 4 V12 engines reported over $300,000 in motors sitting useless at the dock for weeks, waiting on parts and certified technicians. Mercury dispatched factory-trained service teams with replacement sensors and encrypted diagnostic tablets loaded with software updates. Repairs were covered under warranty, but the logistics were brutal. The scale of the recall revealed something troubling. This was not a random failure. It was a systemic issue with the revolutionary steering system that Mercury had marketed as bulletproof. Engineering analysis traced the problem to environmental exposure. Moisture-infiltrated sensor seals pooling inside the gear case housing, thermal cycling from cold starts and hot running created condensation on electrical connectors. Even tiny amounts of water shorted out the steering position sensor. High-speed vibration loosened connections that had passed factory inspection. Salt spray accelerated corrosion. The same environmental factors that every outboard faces became the V12's Achilles heel. Owners reported patterns: steering failures after overnight cold soaks, lockouts following choppy offshore runs, fault codes appearing after washing down the engine. The sensor system designed to deliver surgical precision could not handle real-world marine conditions. But steering sensors were not the only issue. Oil leaks emerged as another chronic problem. Owners reported oil weeping from the lower unit, specifically around the driveshaft seals. One owner with twin V12s experienced a catastrophic failure when an engine lost all oil, requiring a complete powerhead replacement under warranty. The culprit was a failed lower crankshaft seal that allowed engine oil to drain down the driveshaft. Multiple forum discussions documented similar leaks. The Verado design runs the driveshaft directly through the oil pan, which means the engine oil must be completely drained before the lower unit can be removed. If seals degrade, oil escapes slowly but steadily. In saltwater environments, corrosion and buildup around these seals made the problem worse. Some owners went through multiple seal replacements only to have leaks return within months. Getting a V12 serviced became its own nightmare. Mercury required dealers to complete expensive, specialized training before touching these engines. Certification courses cost thousands. Dealers needed proprietary diagnostic software locked behind Mercury's encrypted system, and heavy-duty lifts capable of handling 1,260 pounds. Independent shops were completely shut out. The result was a sparse service network outside major boating markets. Coastal towns with thriving fishing communities often had 0 certified V12 technicians within 100 miles. Owners faced agonizing waits. Boats were hauled out for weeks while dealers waited on parts authorizations from Mercury. Critical components like steering sensors and fuel modules saw back orders stretching 60 days during peak season. Service managers described the system as a logistical maze. Engines sat waiting on crates. Technicians with diagnostic tablets were unable to proceed without factory codes. Customers were furious over boats stuck on trailers during prime fishing months. The financial hit was staggering. Routine maintenance turned into multi-thousand-dollar nightmares. Owners reported repair bills from $7,000 to $22,000 for sensor replacements, seal work, and software updates. Full engine replacements due to repeated failures or catastrophic oil loss topped $73,000. One owner summed it up perfectly: paid for tomorrow's technology, would trade it all for yesterday's reliability. Insurance companies took notice. Premiums increased for boats powered by early V12s. Some insurers added surcharges or refused coverage entirely for commercial operations running quad setups. The risk of offshore breakdowns and the eye-watering replacement costs made the V12 a liability concern. Boat builders started backing away. Boston Whaler quietly reduced V12 availability after warranty data showed elevated claims. Scout boats pulled the V12 from configurations, steering customers toward Yamaha XTO 425 engines or Mercury V8 platforms. Boutique manufacturers slowed adoption, unwilling to risk stranding clients during peak season. The competitive landscape shifted. Yamaha's XTO 425 delivered reliability with a simpler V8 design. Suzuki stuck with proven technology. Seven Marine's supercharged 557 engine offered similar performance with better service access. Innovation came at a cost: downtime, uncertainty, and dependency on limited service networks. Mercury has continued V12 production with updated sensors and revised software. Field reports suggest newer engines show improvement, but trust remains shattered. Online forums advise against V12 purchases until Mercury proves long-term durability. The controversy exposed a fundamental truth. Marine environments are brutal. Saltwater, vibration, thermal cycling, and moisture attack components relentlessly. Automotive-grade electronics need years of testing before marine deployment. Mercury rushed the V12 to market, leaving early buyers to beta test an unproven platform. Today, the V12 stands as both an engineering achievement and a cautionary tale. 600 horsepower, 2-speed transmission, steerable lower unit, all genuinely revolutionary, but also plagued by sensor failures, seal leaks, Guardian mode lockouts, limited service access, and repair costs that rival used car prices. The marine industry learned a hard lesson. Innovation means nothing if the product cannot survive the environment it was built for.